Today we welcome Norman Sadeh. He is a professor in the School of Computer Science at Carnegie Mellon and faculty at CyLab. He is director of CMU's Mobile Commerce Laboratory and co-director of the MSIT program in privacy engineering. He also co-founded the School of Computer Science's PhD program in societal computing. Norman's primary research interests are in the area of mobile computing, the Internet of Things, cybersecurity, online privacy, user-oriented machine learning, human-computer interaction, and artificial intelligence. Among other activities, Norman currently leads two of the largest domestic research projects in privacy, a project on usable privacy policies and a project on personalized privacy assistance. The work that Norman presents in this talk is conducted with a number of collaborators on these projects, faculty, postdocs, and students. So please join me in welcoming Norman for his talk.
Thank you. Well, hello everyone, and glad to be here. So, as you probably know, a fundamental principle of privacy is that we should be able to understand what information about us is being collected and how it's going to be used. And that principle is usually referred to as notice and choice. In practice, the way this is often implemented is through the use of privacy policies. Unfortunately, as we probably also know, and I'm not going to do a show of hands because it's always very disappointing, very few people read these policies, right? And so when you ask people how they feel about their information today, a very large number of them will tell you that they feel that the situation is pretty hopeless and that they've given up trying to understand what's going on, that they understand that a lot of things are going on, but they really don't feel that they have any sort of sense of control over that information. And so there is this general sense that perhaps, we have or we are losing our privacy very fast. This is partly true when you're looking at mobile and the Internet of Things. So for instance, if you look at your cell phone, whether you have an iOS phone or an Android phone, there are lots of different settings that enable you, in principle, to control what information apps on your cell phone have access to, right? And so this information has become increasingly diverse over the years. It could be your location information, it could be your calendar information, it could be camera functionality or your pictures, it could be access to SMS, it could be your contacts list with all the different people that you're calling, right? So very diverse and very sensitive information. And every app typically requests some combination of permissions to access this information. On average, an Android user, for instance, has somewhere between 50 and 100 apps on his or her cell phone. And typically one of these apps might be asking between 3 and 5 permissions. So if you do the math, and if you don't trust me, look at your own cell phone and count the number of settings. If you do the math, it's not unusual for a user to have well over 100 settings that they potentially would have to configure in order to make sure that the apps on their cell phone only have access to information that they feel comfortable sharing with these apps, right? How many of us have the time to actually configure 100 different settings? And that's just for your cell phone and just for the apps on your cell phone. There are lots of other settings on your cell phone that don't necessarily have directly anything to do with apps. And then once you're done with that, you can go to your browser and you can count the number of settings that are available there. And when you're done with that, right, the list goes on. You can go to Facebook, and we can go on and on and on, right? So this is obviously extremely challenging. And while it's great to have all these settings, much better than not having them, in fact, these settings don't amount to very much because people are truly overwhelmed. It's unrealistic to expect people to actually devote the amount of time that they would have to devote to configure all these different settings. And now we're moving to the Internet of Things, right? And the Internet of Things, you don't even have a device anymore, right? So forget about trying to read privacy policies. You walk into a room and you don't even know what devices are out there, what information about you might be collected. So what do I know about this room, right? Is my unique device ID being collected by sensor? Is there some location tracking taking place here? Apparently there's a camera that's videotaping me, and I was told about that, but usually you're not told about those things, right? What else is this camera doing, right? Is it trying to, look at my facial expressions, determine whether, maybe I'm depressed or what have you, right? We don't know about these things, right? So it's extremely challenging. And so by and large, this notice and choice paradigm, while it's great, is actually broken, right? And we need to come up with very different ways, new technologies in truth, if we are going to restore some level of control over our data. And so this talk really looks at work that we've been involved in for the past few years, my colleagues and I, in trying to see whether we could overcome these limitations. We're living in a data-centric economy. More and more information is being collected about us. And as all these diverse information flows arise, it's nearly impossible for us to try to keep up, at least manually. We're not going to read privacy policies. We're not going to configure settings, even if these settings are made available to us. And so the question that I'm going to be asking in this talk is, well, what if instead of people reading policies, we could have computers read policies, right? Could that potentially change things? And how practical is that? And as you might remember, going back 20 years now, right, there's been a number of efforts because people anticipated this problem a long time ago already. There's been a number of efforts to say, well, one way of enabling computers to understand privacy policies would be to get everyone to adopt machine-readable formalisms for representing privacy policies. And so if we could do that, then obviously computers would be able to understand privacy policies, right? And they would be able to understand what choices are potentially being made available to users. And we could do lots of different things with that. But the fact of the matter is there's been a number of efforts to try and do this, and there's been major pushback, right? People who own these privacy policies have attorneys, and these attorneys are telling them, look, machine-readable privacy policies, those are dangerous things because you're really committing yourself very precisely. There's semantics associated with these things. Are you really sure you want to go down that path? And while there are benefits to going down that path, by and large, industry has shown us they're not ready to move down this particular path right now. And so the question is, well, could we just leverage what's available today? And how far can we go with that? And so that will be one of the questions that I will try to look at today. And so obviously, if computers understood privacy policies, right, you can easily imagine that they could then inform you about what's in these privacy policies. And in fact, if computers also had models about what you care about, right, if they already knew what you know, right, they could be very selective in what they're informing you about, right? So even a computer understood a 7-page privacy policy, I'm not clear that I wouldn't want to know everything that's in this privacy policy. In fact, we've got research that I'll share with you that shows that most of the time you don't, right? We just don't have the time, right, to be told about every little detail in every privacy policy. And most of the time, we already expect many of these things to take place. Most of the time, we don't necessarily care. What I'd like to do is I'd like to have technology that sort of tells me just about those things that matter to me. Perhaps those things I didn't know, those things I would potentially find to be somewhat egregious, and then everything else, leave that alone unless I've got a specific question that perhaps I want to ask at some point to my computer, and maybe my computer would be able to answer that particular question. So if we could have computers that understand privacy policies, we could develop what we call privacy assistants, and these privacy assistants would very selectively inform us about things that we would not expect, that we would want to know. And by and large, most of the time, these privacy assistants would remain very quiet, right? Because there's such an explosion of technologies out there. If we had to be told about everything that's going on, it could be overwhelming and it would turn this functionality off in absolutely no time. So I'd really like a technology that perhaps only interacts with me 3 or 4 times during the course of the day and tells me those 3 or 4 things that would really make a difference to me, right? And everything else should take place in the background, ideally. And obviously, if we had that, perhaps these computers, these privacy assistants, would be able to also configure some settings on our behalf, right? If they could learn enough about our preferences, if they could learn enough about what we care about, then perhaps they would be able to configure a bunch of settings, and occasionally when they're not sure, they would ask us, how we feel about certain types of decisions. If we had computers that understood privacy policies, they might also be able to potentially inspect the code, right, that's coming along with these policies and identify issues. Like, in your policy, you're saying this, but your code actually does Y, right? And your policy says X. Maybe you got to either fix your policy or fix your code because there's an inconsistency here. There's a violation. And so that sort of functionality could be very useful. could be useful to developers, could be useful to app stores, right? App stores obviously have built a business model that relies on people thinking that they can trust these app stores to download apps. Very often these apps are developed by people who are not terribly knowledgeable. And so if the app stores could take more responsibility in inspecting apps that are being posted on them and identify potential problems before it's too late, that would add value to developers who lack the expertise and the resources to do this on their own. And perhaps we could even help regulators in this space. So those are the kinds of things that I want to discuss with you, right? And obviously, the question is, well, okay, that sounds great, but you said what if? Can you? How far are we in being able to understand privacy policies? And so, as we know, there's been significant progress over the years in natural language processing, machine learning, and so on. And so, is it the case that this technology is far enough to actually enable us to automatically understand the text of these policies? And so when we thought about this initially, we thought, well, probably not, right? And so a lot of our early work in this space involved developing crowdsourcing models. We thought, well, we're probably not going to be able to do this automatically. And so let's see if we can build tools that will entice a large number of people to look at privacy policies, extract annotations from these policies. And if we can do this at scale, perhaps we'll be able to do the equivalent of enabling computers to leverage, right, some understanding of privacy policies. And so the project that started to look at this is called the Usable Privacy Policy Project. It's been going on now for 3.5 years. And initially, the idea was that we'd do some crowdsourcing, and then we would generate policy annotations, and then based on these annotations, we would start developing technology that would selectively inform users about different things that perhaps they care more about than others. We've done a lot of that, and I'm not going to say much about what we did, but I'll at least show you at least one of the frameworks that we've developed and a set of annotations that came out of this research. One of the things that we learned quickly is that privacy policies, while they lend themselves to crowdsourcing, so some of the research questions that we looked at early on is it even possible to hope that people will be able to answer questions about privacy policies? Can people be expected to even understand privacy policy? Are they going to converge on how to interpret these policies? And so we actually got a fair bit of positive results there. If you have enough crowd workers looking at a policy, they will typically converge on a significant fraction of the annotations that you might want to extract from that policy. And they will rarely converge on annotations that are incorrect when you compare these annotations that they generate with those coming out of experts like professors, law professors working in privacy, right? But occasionally they will not converge, right? And so it's when they do not converge that obviously you have a bit of a problem, but very, very often if you have enough crowd workers, like if you have 10 crowd workers and you say, okay, I'm going to only take those facts where 8 out of the 10 converge, you're going to end up actually with a fairly high level of precision. Your recall, on the other hand, might only be about 75%. That's the sort of results that we got in the early days from this sort of research. What we also realized is that asking people to read entire privacy policies, even as crowd workers, is not terribly realistic, right? So a typical privacy policy will take about 10 minutes for someone to read, and then you ask them on top of that to annotate these policies. Before you know it, it takes them 15, 20 minutes, right? That's not a typical crowdsourcing task, right? Typical crowdsourcing tasks are basically a few minutes in length. So over time, we start developing frameworks that said, well, perhaps we can break down these tasks, right? And so one of the ways in which we've been fairly successful at breaking down these tasks is to say, well, perhaps we could start by first annotating paragraphs, or what we call segments, in privacy policies. What sorts of practices are being discussed in these segments? And then segment by segment, ask people to actually extract annotations, right? And then try to put all this together and see what you can conclude from that. So an example of tool that we developed to do this is being depicted here. This is a tool where we identified between 10 different types of data practices for which we decided to go ahead and collect annotations. And those practices include things such as, first-party information collection. First party referring to the website operator, for instance, or the mobile app, the mobile app provider. So what information do these entities collect? third-party collection and sharing, right? So what about third parties? What information do they collect and do they share through this particular technology, be it a website, being a mobile app, for instance? Looking at user choices. What are the options that are given to users in terms of opting out, opting in, deciding not to use the technology, right? Those are examples of user choices. What sort of notification process does the technology have in place to let people know that the privacy policy has changed? What sort of access rights do users have when it comes to reviewing their information, requesting that it be modified? This is the notion of access in privacy. Also looking at more specific types of issues, such as issues pertaining to European residents or California residents or children under COPA, right? So looking at a number of different types of practices. So we developed a tool that enabled people to say, well, in this paragraph, we're seeing the following collection of annotations. There are some statements about first-party collection. There are some statements about third-party sharing, right? And then from there, enabling them to actually identify more specifically what these statements were, right? So what does this particular piece of text really say about first-party collection or third-party sharing? And so we use this tool to collect a fairly large number of annotations. And the end result is actually available through a website that we've made available to the research community as a way of trying to promote further research in this space. And so this is a website where we also developed graphical tools to enable people to navigate these policies, look at these annotations. So the different colors here that you see, each one of these bars represents a different privacy policy, and the different colors represent different sets of data practices and where they fit within the privacy policy. So this is the beginning of a privacy policy, and this is the end, and these are the various segments, right? So each one of these bars here represents a different segment, and the color codes here represent different types of data practices. So for instance, in this case here, I believe that we're looking at statements about third-party sharing. Here, I think we're looking at first-party collection. I think that's the same here, and then there are other colors that represent different things. It's actually interesting to look just at these colors to see that there are actually some interesting common patterns. So notice that, for instance, this color seems to be fairly prevalent at the beginning of many policies. And as you go down, there's a slightly different mix of colors. Some work that we did at some point, I'm not going to talk about that, involved looking at hidden Markov models to try to understand what sorts of typical sequence of statements you find in privacy policies. There are lots of very interesting patterns that you can discover just from doing that. But just to give you a slightly better sense for the sorts of annotations that we've been playing with, and sort of continuing to rely a bit on the graphical interface that we have here, you can click on any one of these colors, right? And then you can see here the text of the policy and the corresponding statements being highlighted in that color. And so suppose that I click now on first-party collection and use, which is that color I was showing you earlier. I'm going to now see just those paragraphs that refer to first-party collection and use, or what I'm going to refer to as segments moving forward. But I can also go deeper and look at the finer annotations that we've been collecting. And I can see here that I've got a number of ways to look at things at a finer level, such as, for what purpose is this information collected? Is it for advertising? Is it unspecified, right? Is it for security reasons? Is it for analytics? And so on. And so you can actually zoom in on these different kinds of annotations. And the reason why I'm spending a little bit of time here showing you these annotations is to give you a sense for the kinds of things that we would like to automate moving forward. And so very quickly, we're going to move into a part of the presentation where I'm going to tell you what we have done to try to leverage these annotations and start building classifiers that can automatically extract those types of statements. Here, we're looking at user choice and control. So what are the options that are given to users? Again, different ways of filtering this information. And then if you want, you can pick any one of those things interactively, and you can say, well, show me all the opt-out options that involve contacting the company, right? And in this particular case, there are 5 such statements in this particular policy here, and you can zoom in on those statements, and they're being highlighted there. So you could potentially click on these segments here as they're being highlighted and jump straight to the corresponding segment in the policy. So is that a tool that we want to give to end users? I don't think so. Is that a tool that people working in privacy are interested in? You bet, right? Nobody has ever done this. So this corpus is fairly unique. There's a lot of interesting stuff that you can do with this. But it's also static, right? At least the way I'm showing it to you right now. It's a static corpus. That means we, spend a lot of time and effort collecting all these annotations. We recruited actually law students that were trained with the Annotation Tool, and then we collected all these annotations. In all, we have 23,000 annotations that we've collected that correspond to about 115 policies. And so this is a unique corpus in this space. There's nothing else like it out there. But it obviously takes a lot of time and effort. And as I've already pointed out, one of the things that we've learned is that hoping to rely solely on crowdsourcing is probably not going to work very well. It's probably not going to scale. And so one of the things we tried to do early on also was to say, well, perhaps we can have a mix of automation and crowdsourcing, right? So perhaps we could build some classifiers for some tasks, and then we were not quite sure, based on the automated technology, let's fall back on crowd workers to help us understand what's going on, and perhaps that mix can get us somewhere. And I think it could still get you somewhere, but we decided that even that probably was placing the bar a little high in terms of scalability. And so what I'm going to be talking about for the rest of this presentation is technology that aims at fully automating this process. And so we're going to try and see what can be done, how far we've been able to go, and what sorts of tools we can already build based on the technology that we have available today, based on this research. And so the observation is, well, crowdsourcing has scaling issues, right? Could we automatically extract privacy policies? And so a first task that we looked at, and we're still looking at it, but we've actually made quite a bit of progress in this area, is just to see whether we can come up with a color coding for these segments in privacy policies. And I'm going to use segment to refer to what might amount to a paragraph. It's not exactly a paragraph. We've got a slightly finer way of segmenting privacy policies. But just to give you an order of magnitude, a typical privacy policy has in the order of about 40 segments to label. And so you want to know, what are these different segments talking about? Are they talking about first-party collection, third-party sharing, user choice, deletion, and what have you? And so the task here is to take one of these segments, right? And a segment is basically text like the one that's being displayed here at the top. And then looking at the 10 different types of data practice categories that we've identified, which is a fairly comprehensive set of data practice categories, can we predict which one of these categories are being discussed in that particular segment? And so the approach that we've taken is one where for each type of data practice category, we've built a different classifier, right? Because a given segment might be discussing more than one type of data practice category. And so the idea would be to you just apply your classifiers, right, your 10 classifiers to that segment. And then in this case, we've identified that there's one practice only being discussed. So this is an example where there's only one color. If you want in the UI that I showed you earlier, in this case, we've identified that there's a statement about third-party sharing, right? And so to train these classifiers, we had basically about 4,000 different segments, a number of different categories, 10, and we had annotations from 3 different annotators, as it turns out. And so we decided that it would be reasonable to basically take as our gold standard any annotation that's identified by 2 annotators out of 3. There are actually ways of refining this. As it turns out, annotators, at least the ones that we used, don't make too many mistakes. And so you could conceivably even go down to 1 if you wanted to, and we've been playing with different assumptions to see how that changes things, and by and large, results are pretty stable. You get a few more annotations if you're willing to go down to 1, because occasionally there will be only one annotator that sees something and the other 2 will not necessarily have seen it, right? It's actually a very tedious process to annotate these privacy policies, as I've pointed out earlier. And so the approach is to develop one classifier per practice. And one of the things I'm not going to do is I'm not going to turn this into a talk on natural language processing. So I'm going to sort of do a little bit of hand-waving here in describing these techniques, because what I want to get to is give you a sense of what's possible without necessarily telling you exactly what the underlying algorithms are. There are papers on this that you're welcome to take a look at, just accessing a website or potentially emailing me if you want. So these results here with a wall of numbers will be explained in about 1 minute. Right? And the key thing here to realize is that there are lots of different techniques that you can use out there. Sometimes the simplest techniques in NLP actually work best. So logistic regression corresponds to LR here. SVM refers to support vector machines, for those of you who work in that area, pretty typical sort of machine learning technique. CNN is the slightly fancier technology, right? Does anyone know what CNN stands for? Anyone work in deep learning? All right, so convoluted neural networks, right? So these are these multi-layer, right, neural network models that you can build. And what's interesting here, and we're going to leave aside the first 3 columns where we try to see whether prediction just based on sentences instead of segments could potentially be better. By and large, these results show that the segments are actually the way to go. You need a bit more context than just a sentence if you want to be good at predicting these things. And so by and large, what you're seeing here for the 10 different data practice categories that we have been looking at is you're seeing that those results are not bad, right? So for those of you who don't really know how these things are reported in machine learning, you typically look at precision, right? The fraction of labels that you have that are correct. Recall, that means the fraction of labels that you've actually been able to identify out of total number of fractions, and F1, which is a metric that tries to reconcile both of these views, prediction and recall. And so an F1 metric of 0.8 is not bad at all, right? I mean, and so we're looking at roughly, as you can see here, there are obviously data practices where we do a bit better and data practices where we're doing worse. But look, for instance, at first-party collection, right? We're getting about 80+% in accuracy, especially if you look at the neural network models, right? 83 in precision, 83 in recall, and F1 83. That's not bad at all, right? So we're catching more than 80% of those segments that address first-party collection issues, and most of the time we're actually correct in our prediction. This can go even higher. So when we're looking, for instance, at user access, edit, and deletion, which is the 4th entry here, you see that, for instance, with CNN, we're getting an accuracy of a precision of about 0.92. That's actually very reasonable, but it's not 100%. And so those are the 2 points that I want you to remember from this. It's not 100%, but it's not bad. Is there a question?
What's particularly hard about data retention?
Data retention. So some of these things are easier than others, but the language that you use when it comes to data retention is not necessarily, there's a lot of diversity in language. And it's not just about saying there is a sentence that says, that talks about data retention, although in retention, in this case, you're going to be looking for obviously some period of time, or a statement that says we're not really telling you, right? Those kinds of things. One of the things I've not really pointed out very much is there are a lot of ambiguous statements in privacy policies. And in general, a big challenge in annotating these privacy policies, and that's something that we learned very quickly when we build these crowdsourcing approaches that we focused on early on, is that if you give users only 2 options, is this practice present or not in this policy, you're going to make it very difficult for crowd workers to give you an answer. You're often giving them an impossible task. So you've got to give them the ability to also say, well, the policy doesn't say anything about this, or the policy is ambiguous about this, and that's a valid answer, right? More often than not, that will be, in fact, the correct conclusion. And so that's obviously part of the challenge, and that was one reason why we also looked at whether crowd workers can even be relied on in the first place, because this was not entirely obvious to us to start with. So another task, right, and so I'm sort of trying to give you a bit of a flavor for what's possible here without going into a lot of details. Another task that's obviously important, if you refer back to the principle that we're discussing here, which is notice and choice, right, is the choice part of these privacy policies. So what do these policies really say in terms of what you as an end user, as a consumer, have control over? Well, most of the time, and so mobile apps in that regard are somewhat nicer because there's actually a set of settings that you have control over, and they're all in one place. But if you go to a typical website, when it comes to user choice, what you're going to find is, maybe 3, 4, 5, 6 pages of text, and somewhere, lost in the middle of that text, there will be a few statements about choices that you might have available. Occasionally, these choices will include a hyperlink. That hyperlink might lead you to another page, where after reading some text, you might find that there's another button, and you might be able to opt out. Occasionally, this hyperlink will lead you to, a phone number, and then you've got to call that number. Occasionally, there's a mailing address, and then you've got to drop an envelope in the mail. and occasionally there's a statement somewhere that says, really, you don't have control over this, or your only choice is to just not use or cite. Right? Those are the kinds of choices that you find. And so it's important to see to what extent we could go from a user having to read perhaps 5-7 pages of text and looking for these choices to technology that could just extract those choices for you and just make them available, let's say, through a plugin, which is something that we're working on based on the results that I'm going to show you here. So how good can we be at just extracting these choices from privacy policies? The answer is pretty good, actually. Right? And so these are results that we published. We actually have better results today. So at a high level, and so what are we trying to do here? We're trying to identify the different kinds of choices that are available to users, the mechanisms whereby they can opt out, opt in, right? There are actually a number of different choices that you want to distinguish between. Today, we're getting a precision of about 0.92%, right? With a recall of about 2/3. That means we're going to be able to extract automatically about 2/3 of the choices that are present in privacy policies, and we're going to be pretty precise in identifying those things. So it's going to be very unlikely that we're going to show you a choice that doesn't amount to a choice, right? And so those results are very promising, but again, and this is the key message here, and that's why I'm going relatively quickly over this. The key finding here at a high level is that, hey, this technology does give you something. It's not 100%, but there are some pretty meaningful results that you can extract from applying this sort of technology to privacy policies. And so the next question is, okay, great, write papers, submit them to NLP conferences, I'm sure, and we have, right? But what does it mean, practically speaking, from a privacy standpoint, right? Can I do anything with 80%, right? Can I do anything with 92% precision? And so that's the question that we went on and tried to answer, and that's what I'm going to spend the rest of the lecture looking at. So could this be enough, for instance, to look at compliance issues, right? So could I look at the text of these privacy policies and potentially right there, on the basis of these technologies, identify potential compliance issues that a regulator might want to look at, that an app store might want to look at, that the developer would be interested in learning about. And so what I'd like to do is I'd like to tell you in particular about our work in the context of mobile apps. And so what we've done here is we've combined two sets of technologies, the technologies I've described so far, which are technologies to extract statements from privacy policies. We've combined that with what is known as static code analysis. That means effectively technology that involves writing scripts that are going to look at the code of mobile apps. And so one of the things that you want to do is you want to, for instance, see whether what the mobile app does based on its code is actually consistent or inconsistent with what the policy says it does, right? If these things are not consistent, you've got a problem, right? So this is, an example of misleading users, something that the FTC and other regulatory agencies really don't like, and you can get in trouble for. So can we actually do that, right? And so what we developed is effectively a pipeline where we are systematically scanning apps on the Android Play Store. We've not fully scaled that, but I'll present to you results where we looked at 20,000 apps. We spent about 6 seconds analyzing an app, looking at its code and looking at the text of its privacy policy, and effectively identifying potential compliance issues. Now, you might say, well, can you extract everything in a privacy policy? I've already shown you that we can't, right? The question is really, can you extract things that are interesting enough to identify enough potential compliance issues that this would be useful, for instance, for an app store, for a regulator, for a developer? We developed a tool in particular that looks at a combination of issues that are potential compliance violations. We looked at a collection of regulations. Not all regulations apply in all cases, right? So this extends to, for instance, CALOPA. We've worked actually closely with the California Office of the Attorney General. They've piloted the tool that I'm going to be discussing. They had a press release in October on the tool, and we're continuing to work with them on that. There are several other regulators that since then have approached us, but Google, for instance, might be interested at some point in potentially deploying something like that also on its app store whenever someone uploads a privacy policy, because they realize that they probably would gain from having apps that are less often in trouble and in violation of various types of privacy regulation. So what are the kinds of things that we're looking at? Well, the first thing that you can look at is, does this app even have a privacy policy? Now, this doesn't even require any NLP, but there are tons of apps that still don't have privacy policies. And an app is not necessarily required, at least here in the US, to have a privacy policy. But there are conditions under which it has to have a privacy policy. So for instance, under CALOPA, and CALOPA, for those of you who don't know, is the California Online Privacy Protection Act. And in many ways, you can view CALOPA as sort of setting the bar for privacy in the United States, right? So I'm not aware of too many vendors, right, selling technology for everyone except residents of California, right? People are not willing to distinguish between whether or not you're a resident of California or not. So by and large, CALOPA sets the bar that everyone is going to be aiming for. One of the things that CALOPA says is if you collect sensitive information, PII, you need to have a privacy policy. It's that simple, right? And so, and they specify the kinds of privacy, the kinds of personally identifiable information that require having such a policy, like location information, unique ID, etc. And so one of the things we can do is we can look at the code of an app, see whether actually it collects that information, and see whether or not it has a privacy policy. And there are a number of different places where privacy policies can be, so it's not necessarily as straightforward as you might think. But after you've checked all these places, if there's no privacy policy that has been found, there's a decent chance, right? And the privacy policy could be within the app, it could be on the App Store, it could be on a separate website. There's 5 or 6 different places where you might want to look. If after you've looked at all these places, you still haven't found a privacy policy, there's a very decent chance that this thing doesn't have a privacy policy. So that's an example of a violation you can very easily identify. But you can certainly go beyond that. You can say, well, this app, for instance, collects and shares my location information with third parties. And the policy doesn't say anything about this. Well, it should under CALOPA, or it says otherwise, which is even worse, right? That would be a violation also. So there's a whole range of things that you can look at. So we've looked at collection of unique identifiers, collection of location, collection of contacts information, as well as the sharing of this information. We've looked at NPC, which means basically how do you notify users about the change in privacy policies, again, something that's actually required under different types of regulations. What do you say in terms of access to information, ability to edit information, and the like. Okay, and so we've developed this tool, right, which you can use. You can actually specify an app, or you can say, hey, crawl the App Store and start looking at these apps systematically. And so this is the sort of results that we're getting here in terms of looking at these different issues. NPC, this is notice of privacy change. NAED has to do with access and editing information. CID, CL, CC, the first C corresponds to collection. And then, so unique ID, location, and contacts. And then SID, SL, SC, the S corresponds to sharing of ID, location, and contacts, right? And so the sort of things that you're looking for in this case is actually not the presence, but the absence of statements, right? So we're looking for apps where the code of the app clearly does something, like it collects your location information, or it shares it, and the policy either says nothing or says otherwise. And so now instead of looking at an F1 metric in terms of positive statements, we're looking for absence of statements. And those are the kinds of numbers that we're getting for these F1 values. Very decent numbers, as you can tell here, right? 80% and above. And then we're looking also at code analysis, right? So can we, for the same practices, identify, in this case, this is F1 positive, right? We're identifying that positively this code does this, right? And looking again at whether or not we are fully accurate. So you might say, how can you not be fully accurate, right? If it's in the code, it does it. Well, not quite, right? So apps, unfortunately, are not perfectly written. So when you look at an app, right, you might find, for instance, a function somewhere that seems to be doing something. But if you follow the flow of that app, that part of that function may never be called, right? And so you could conceivably, and there are other things that could potentially lead you to making some mistakes. But by and large, we seem to be doing fairly well. And there's still room for improvement, right? And so what happens when you put these things together? What are the kinds of findings that you come up with? Well, the first finding is on the one hand, technically trivial, and at the same time, very significant, right? So this is the number of apps that don't have privacy policies and really should have privacy policies. So when we looked at these 18,000 apps, 17,991, right, about 48% of those apps, as far as we could tell, didn't seem to have a privacy policy. We actually went on and did some finer inspection, looking for additional places where these policies might be. We discovered that a few of these apps had policies in places that we didn't expect them to be. But by and large, the vast majority, so this is the 17% of these 48%, 12% of those apps also didn't collect any PII, so under CALOPA, they were not required to have a privacy policy. 71% of these 48%, right, so 71%, this is about over 6,000 apps out of 18,000 apps, so about a third of all the apps didn't have a privacy policy and were actually collecting information that required them to have a privacy policy. That's an interesting result, right? So right there, it gives you a sense for what is the state of affairs when it comes to mobile apps and compliance. And this is not entirely a surprise, right? So the sophisticated organizations that develop app, right, the Googles of the world and so on, those guys have privacy policies, right? They've got attorneys, they've got resources, they understand that they need to have a privacy policy. The vast majority of apps out there are developed literally by two guys in a garage who've got no clue. They don't even know that there's a need for a privacy policy. And when it comes to writing privacy policies, they realize there is a need to have one. They're going to write something terrible, right, as we're going to see in a minute. Right? So there are clearly examples where this sort of analysis can make a difference. And this is not rocket science. No, when it gets more interesting is when you start looking at the finer, right, the finer analysis and what we can actually identify through our policy analysis. So this is, again, extracting statements from privacy policies and identifying what's going on. So 46% of apps seem to describe the notification process for policy changes, but clearly a bunch of them don't seem to describe anything about that. 36% seem to describe user access, edit, and deletion rights. That means that the others do not. More interesting things is, for instance, sharing practices. So for instance, location, right? Only 12% of the apps that we looked at and that had privacy policies were actually disclosing the potential sharing of location information. Our analysis, when we looked at the code of these apps, suggests that there's a much larger number of apps that actually share location information. So again, and this is obviously finer analysis based on natural language processing as well as static code analysis. Right? So these are the results from the code analysis, where we start comparing the results from looking at the text of the policies and looking at the code of the apps. You find tons and tons of issues, right? So, for instance, the sharing of a unique ID, right, seems to be about 61% of apps that might be non-compliant, right? Sharing of location, about 8% of apps seem to be non-compliant. So clearly, very meaningful numbers here that are, as you can imagine, of lots of interest to regulators. And so we've been piloting, as I said, this technology with the California AG. Can they take these results to the bank? No, they cannot. So the biggest challenge is still scalability. What we can do is we can flag all these problems, but our accuracy is not 100%. Right? So if the regulator has the resources to perhaps look at 100 apps per month, right, we need to actually find a way of prioritizing these results. Right? It's not enough to say, well, here are the 9,000 apps that seem to have compliance issues out of the 18,000. Go have fun. Right? So they're actually asking us to prioritize these results so that they can focus on the more interesting ones from their perspective. And what is most interesting might vary from one month to the next, right? It's not that they've got absolute standards. In fact, if they had fixed standards, right, this could easily be exploited by people with malicious intentions. So you want to sort of mix it a bit from one month to the next, ideally. So the next question is, right, how about end users, right? So the technology I've shown you here could definitely be useful for regulators, for app stores, and for developers themselves, right? So we're actually looking right now at also introducing this technology in the context of IDEs, so that if you're a developer and you're writing your privacy policy, we might say, well, by the way, looking at your code, you should probably include the following statements in your privacy policy, things that very often people might be missing. But how about those end users, right? Ultimately, notice and choice, this is about informing users. So could we actually also help users understand what privacy policies are saying, and could we help users also configure these choices that are potentially made available to them? And so that's another part of the work that we've been focusing on. One of the first questions that we ask is, what do users already expect? So if you go to a website and you ask a user what they expect the website to be collecting and what they expect the website to potentially be sharing, people have all sorts of ideas about what's going on. Some of these ideas are correct, and some of these ideas are incorrect. Telling people about things that they already expect may not have a huge amount of value. Telling them about things that they don't expect would certainly have a lot more value. And so one question is, how much of what a website does is actually expected by a user and how much is not? We've actually conducted experiments doing that. So we walked people through a number of different websites, some websites they were familiar with and other websites they were not familiar with, and asked them, what do you think this website is collecting? So you show them, for instance, a screen like this, and you try to find out, from their answers what they're expecting and what they don't. And you get a very rich, and I'm not going to go into the details of all these stats, but you get a very rich picture with very nuanced results about what people already know and what they're more likely to be surprised about. And when you analyze these results closely, you find that there are probably about 70% of the statements made in privacy policies that you don't necessarily need to show to users. And so that suggests that, hey, there's potential here, right? We could, it's great to collect all these annotations from privacy policies, but there's clearly more statements that are being made in these policies that the user would want to see. Building models of what users care about, what they already know, might help us trim that down. And so 70% sounds like a good number. It's nowhere near where we want to be, right? As I said, our goal ultimately would be to tell you maybe 3 or 4 times during the course of the day. 70% is not going to get you there, but certainly progress, right? Another question is, how about all these permissions that I was talking about at the beginning of this talk? So I argue that, as an app user, we have way more permissions on our cell phones that we're able to configure. No one has the time to configure 100, 150, 200 different settings. So is it possible to also learn people's privacy preferences? And obviously in the context of mobile apps, all these choices are already exposed to you, right? So we're not going to try to extract them from the privacy policy. We're going to find them right there, right, through the permission interface that are made available in iOS or Android. But could we actually figure how users would want to configure these settings? And so we conducted experiments, again, with real users carrying their Android phones and their regular Android phones and looking at how we could motivate them to actually play with these settings. A typical user doesn't look at these settings, right? And so if you want to learn their preferences, right, you've got to do something to get them to pay attention to these settings. Otherwise, you're not going to learn anything. If you just take someone's settings and try to learn from that, right, you're not going to learn very much, because one of the things we found, and don't have the time to really describe this research, one of the things we found is that you take a random person and you show them the apps they've got on their phones and what information these apps are collecting, and they're extremely surprised and very upset most of the time, right? But the fact of the matter is they never look at these settings, and so the settings are not really aligned with their actual preferences. And so one of the studies that we conducted involved popping up a message once a day to let people know about certain things that were happening on their phone and motivate them to actually visit these settings. And then we looked at what settings they arrived at the end of a period of a week or 10 days. And so those are the kinds of things that you would show to users, right? So your location data has been accessed 1,222 times over the past week. Here are some of the main offenders, right? How do you feel about this? Would you like to go on, or would you like to review your settings? And as you can imagine, many people go and review their settings. So once you've collected all these data from a bunch of users, right, the time is you are in a position where you can say, well, let's analyze this data. Let's see what sorts of correlations we might be able to identify there. And so even very simple machine learning techniques like clustering techniques can actually give you quite a bit of predictive power when it comes to figuring how a user would want to configure his permission settings. So this is an example of a paper that was published last summer. It actually got the Best Paper Award at SOUPS. And this is a collection of 7 profiles that we're able to identify using very simple clustering techniques, hierarchical clustering techniques. Those are the more organic types of clustering techniques, showing how you can organize users in 7 clusters of like-minded users when it comes to configuring permissions on their cell phones. So each one of these profiles here corresponds to a different group of users. The horizontal axis in each one of these profiles corresponds to 6 different permissions, right? This is location, calendar, contacts, camera, and so on. And the vertical axis here corresponds just to Google Play Store categories, different categories of apps. And obviously different people feel differently about whether or not they're comfortable granting some permissions to apps based on whether it's a game app versus a utility app or some other type of app, right? Social networking app and the like. And so there are clearly people with very different preferences. So it's not the case that a one-size-fits-all approach where you would say, well, nobody wants to disclose their location for advertising purposes on game apps, right? That's not true. There are actually people who are quite okay with that, but there are people who are not.
So what did you use as your distance function here?
Say that again?
What did you use as your distance function here?
So there are a number of details that we can go into, but we did hierarchical clustering. Once we had built the clusters, then we applied SVMs, and then eventually the SVMs were used to figure the profiles, right, that I'm showing you here. And then the final step here is when you get a specific user, you look at the mobile apps that they've got on their cell phone. You ask them a few questions to determine which profile is the best match for them. You do that using decision trees that are generated using C4-1 technology. So those are the kinds of screens that we use in this study. So this was piloted with 49 real users on their real Android phones for a period of 10 days. And they would be asked a few questions, between 3 and 5 questions. We figured that 3 to 5 questions is enough to tell you which cluster you belong to out of those 7 clusters. And then we would come up with a bunch of recommendations. And about 80% of those recommendations were adopted by users. And then we tried to entice them to revisit these recommendations that they had accepted, again, using what we call nudges, basically pop-ups that say, hey, did you know that this is happening? Try to get them to entice to revisit decisions they had accepted just to make sure they were not nice and they were not just accepting our recommendations because they were coming from us. And the vast majority of people just kept the recommendations they had accepted. Only about 5% of these recommendations were changed. So this stuff now has been improved a bit more. It's actually available on the Google Play Store. So if you have a rooted phone, unfortunately you need to have a rooted phone to use this because we modify your settings after you've told us who you are and whether or not you accept our recommendations. But you're welcome to play with this if you want to. All right, so we're reaching the end. Right, so our overall vision here is to leverage these sorts of technologies and build privacy assistants that are not limited just to helping users configure permissions for mobile apps, but we'd like to also be doing this in IoT context. So you walk into this room, you discover what resources are in the room, or at least you have an assistant that's able to do that. You discover what settings are available, if any. You discover what privacy policies are associated with these various resources, and you selectively notify users about things that they might care about, and you configure whatever settings might potentially be available based on models of the user's preferences. So can you actually do that? Well, one of the things that you need to have in place to try to do something like this is you need to build some kind of an infrastructure so that as you walk into a room, right, you can actually discover what resources are in this room, right? I was at RSA not too long ago, and there is this huge hall, exhibition hall, that's under camera surveillance. And you go down the escalator at the Moscone Center, and when you get to the bottom of the escalator and you walk another 10 yards, there's a tiny little sign like this. And this is a room that's at least 50 times this room. But there's one place where there's a tiny sign. It says, this room under camera surveillance, right? You can imagine how many people notice this, right? So we'd like to go beyond that, right? So the idea is that we could actually have registries where people who deploy resources would, and there's no law to force them to do that, but if they wanted to, they would be able to declare the presence of these resources, and you'd be able to query these registries. You'd be able to discover these registries as you move around through your privacy assistant. You'd be able to query these registries, find out what resources are in your vicinity, and you might also be able to then discover elements of privacy policies associated with these technologies, right? So some technologies might be just, off-the-shelf technologies. You buy a Nest, right, and you deploy it somewhere. There's a privacy policy. We can actually apply our technology, read this privacy policy, and populate the corresponding entry in the registry. If it's Carnegie Mellon and there's a crazy professor that has deployed some crazy sensors, then we could ask the professor maybe when he files the IRB whether or not he would be willing to potentially populate our registry. So we've actually built these registries, right? And so the protocol is one where you walk around with your privacy assistant on your smartphone because that's the device you have everywhere you go these days. The smartphone keeps on looking for registries, It queries these registries based on your location. It discovers things that it's got to warn you about and tells you also about settings that might be available. And so this registry is available. No, it's actually been deployed. So this technology is actually deployed at UC Irvine, and there's an early deployment here also at Carnegie Mellon. And we plan to make it more widely available over the months to come. And so one can go and effectively declare the presence of these resources. All these fields are optional. So we're not really requiring, we don't expect the world to necessarily follow one single approach. We just want to make it easier for people who want to declare the presence of resources to do so. And if they decide not to, there's nothing we can do about it. But there are lots of incentives for people to actually go down this path, right? Why? Well, in general, surprising your customers is not a good idea. Right. Now, if you're TSA, you're probably not going to use this technology to let people know about all the different gadgets that you might have deployed, as people re-enter the country. But in other cases, whether you're a mall, whether you're in Europe, where there are actually regulations about what you need to tell people, these technologies will lower the bar and make it a lot easier, in fact, for people who do feel that they should be disclosing what information they're collecting about you and what settings are available to you. Will make it much easier for you to do so, right? So this is effectively the workflow that you go through as a system administrator, right? You can declare your resource, you can declare the type of context, so where is this resource deployed, which floor, in the CIC building is it being deployed, you can talk about what information is being collected, you can go actually down to a fairly fine level of granularity, disclosing things such as how often do you collect this information, at what level of granularity, whether or not you anonymize this data, whether you aggregate it, and so on. And we've developed, along with this, protocols and also a privacy assistant for IoT that you can download on your Android phone that enables you to walk around and start discovering these resources. And we've not limited this to privacy. So our view is that privacy is great, but you're not going to really get tons of people to download this just purely for privacy. And so in the deployments that we've got, for instance, at UC Irvine, this assistant also enables you to discover apps. So if you want to navigate a building, right, there might be an app that is available for that building that tells you, where the printers are located, where's the lounge. It might tell you, about various meeting rooms. It allows you perhaps to reserve a meeting room depending on what your access rights are. And so if you decide that you want to have this app, you can discover it through this registry, and then you can download it on your cell phone. And as you do that, you're also going to be offered some information about the privacy implications of using this app, the privacy implications of entering this space, and whatever settings might be available. So in this particular case here, there's a setting that enables you, for instance, to decide whether or not you want location tracking to be enabled as you walk into the building. And if you say yes, some people might be able to find you. If you say no, then you can just go on incognito into the building. So as I said, this has been deployed, and we obviously have a lot more work to do. So it's not like this is a solved problem, but this is ongoing. Lots of interest from industry. We're looking at how to make this compatible with a variety of different technologies that are available in the home, the Nest products and the like, technology that are being deployed on campuses, technology that are deployed also in the city, right? Warning you about surveillance cameras, right, around the city and those kinds of things. This is all falling within the scope of what we're trying to accomplish here. And so this is going to effectively be the end of my talk. I think I've already exceeded my time, but I hope that you found this to be interesting. So I tried to outline research in two closely related projects. One project that's trying to automatically extract annotations from privacy policies, trying to show you the kinds of tools that we can build using results that we have available already, and then showing you also how we might be able to take this one step further, develop models of what people care about, what their preferences are, and using then these two technologies together to automatically notify them about things that they would want to know about, and potentially also help them configure settings. And that effectively is the end of my talk. If you have any questions, I'll be happy to try and answer them. Thank you. Any questions? Yes?
Have you looked at all into language in these privacy policies that seems like it means something, but if you understand the legalese of it, it means something else?
Yes, we have. Actually, we're working on a paper that was also part of an effort that we conducted in parallel with the Office of the Attorney General in California. So under CALOPA, there are some guidelines about, for instance, disclosure of PII that's being collected and shared, and expectations also about identification of third parties with which you're sharing information. And so we've actually conducted a human subject study where we collected statements from a variety of different privacy policies that pertain to the collection of PII and the sharing of PII with third parties. We then annotated these statements ourselves with people from the California AG who presumably would know how to interpret this under CALOPA. And then we basically conducted a crowdsourcing effort where we went to Amazon Turkers and asked them a number of different questions to see whether or not they understand what these statements really mean. And it's very clear that there are some cases where people understand what's being meant. And there are many cases where if you read these things too fast, which many people do, you're going to reach the wrong conclusion. You're going to think, so a typical mistake that users make is to think that because a privacy policy doesn't touch on a given subject, it amounts to saying that it doesn't really engage in a given practice. While in fact, it's exactly the opposite, right? And so very often you cannot tell whether or not a site engages or doesn't engage in a practice because it has no statement about it. And a natural a natural tendency for people is to say, well, it doesn't say anything, therefore it's probably not doing this, is actually wrong, right? So there are actually very common mistakes that people will make and that lawyers would interpret very differently. Very good point, yes. Other questions? Well, thank you very much.